Okay, notice on this problem it says use the empirical rule. Sometimes it will say use the empirical rule, and sometimes it'll say use the table. I'm actually going to do this problem both ways. So we'll first follow the directions, and then if you want to watch the rest of the video, I'll show you using the table, and we'll see how close the two answers really are. They should be close, but slightly different. Okay, what does the empirical rule say? Is that notice right here, I'm looking down here at the bottom at this distribution, and right here in the middle is the mean. Now what it says right here is 68% of the data will lie within one standard deviation. Well, half of 68 is 34. So notice on one half they have 34%, and on the other half of between the mean is another 34%. So all my data, 68% of my data, should fall right here somewhere, okay? Then 95% of my data is within two standard deviations. Okay, so if you take 95 and you divide it by 2, you get 47.5, okay? So what that's saying is 47.5% should lie to the right, another 47.5% should lie to the left, okay, of my mean. Remember, the mean is your average. Well, look, if you add up these two values, 34% and 13.5%, notice that does indeed, can't get my decimal point to work, 47.5, okay? And then, look what it says, 99.7% of the data lies within 3 standard deviations. So only a little tiny 0.0 or 0.3% lies right here in the tails, okay? So let's keep this in mind while we attempt to solve this problem. Okay, so this is my rough little bell curve right here for a normal distribution. I'm going to put my mean right in the middle, and it tells me my mean is 16, okay? Each standard deviation is 4 ounces. So when I go one standard deviation over here to the left and to the right, think about it. If I add 4, I would get 20. And if I subtract 4, I would get 12. Okay? This is one standard deviation. And let me put this in here. This is one standard deviation on each side. Okay? So I already know, according to my data right here of my empirical rule, 68% of my data should lie within that. Okay? Now, think about this. They want to know if it falls between 8 and 20. Well, I've already got the 20 right here, but I need to go a little bit further to the left to get to 8. So, you know, my standard deviation is 4, so subtract 4 from 12, and look at that, I get 8. So I'm going to come over here, and that's going to give me 8, and that's another standard deviation. Every standard deviation is 4, okay? It wants to know what percent of my data lies within that. Well, look right over here in your chart. I know that this right here is 34. I know this is 34. And I know this section right here is 13.5. If you add all that up, get your little calculator out, add that, you get 81.5% is going to lie in that area right there. Now, here in a second, we'll do that, and we're actually going to use the table and see what the difference is. But I want to do the next problem real quick. Okay, so I'm starting here with a nice clean slate. Remember, my mean goes in the center. My standard deviation is 4, okay? They want to know what percent of my parcels weighed more than 28. Okay, so remember, I'm going to look down here. When you look down here, 50% here is to the right, and 50% here is to the left of the average, okay? So this area right here is 50%. Now I'm going to clean that up real quick. All right, since we're talking 28, let's keep going over and adding 4, because that's my standard deviation. So if I add 4 to 16, I get 20. That's one standard deviation. If I add another 4, I get 24. That's 2 standard deviations. If I add another 4, I get 28. Okay, there's where I'm at, finally. So what they're wanting to know is what percent lies right here in this tiny, tiny little tail. Well, notice I've got 3 standard deviations right here. So I've got this one, and this one. So you can add those together and subtract them from 50. So let's add these three together real quick, and what do you get? Okay, it looks like you get 49.85. Okay, so if we subtract that, we're going to end up getting 0.15%. There's just a tiny, tiny little percent down there in that tail. So the odds are not greater that the percent of the parcels will weigh more than 28. Okay, so that's using your empirical rule. The only way that really works is if your numbers, are really nice and even. But the problem is, what if I would have said what percent of the parcels weigh more than 26 ounces? Or, they come between 15 and 18. Well, notice none of those numbers are right here when I add and subtract. They're not divisible by 4. So that's when we like to use the z-scores, okay? So let's do these exact same problem, okay? And let's see what answer we get if we use the table and the z-score. So we're going to still use this lovely equation for the z-score, where this right here is your mean, and this value right down here is your standard deviation. And this value is what we're wanting to test. Okay, I still like to think about my bell curve. So let's think about this. My mean is 16 right here, because they tell me that, and they want me to find it between 8 over here somewhere. You don't have to worry about adding and subtracting. I just know 8 goes to the left of 16, and 20 is somewhere over here to the right of 16. Okay, it doesn't matter which one you do first. Let's go ahead and find z of 8. So since I'm trying to test 8, I'm going to do 8 minus the mean all over the standard deviation. And when you do that, that gives you -2. Now, when you go to the table, just look up the absolute value of -2, which is 2. So I'm going to use this double bar here for me just to represent the value I get on the table. So let's go to the table and let's go find 2. Let's see, it's not on that one. Right here. And do notice real quick that every other column, the first one is the z-score, and then the next one is the area under the curve. And it just keeps going. Z-score, area under the curve. Okay, but I'm looking for 2, which is right here, and the area under that curve is 0.477. So I'm going to go back. So that means this area in here between 8 and the mean is 0.477. Now let's do the same thing, but let's do it for 20. So you don't have to put the little 20 down here. I do that for myself. So we're going to do 20 minus the mean divided by 4. We get that, and we get 1. That's my z-score. So now we're going to go to the table to find the area. So let's go to the table, and here's 1, and that area is 0.341. So this area under here is 0.341. So that total area, add them together, and what do we get? 0.818. 818. Now, that's the area under the curve. If you want to turn that into a percent, remember you would multiply by 100, which moves this decimal over 2 places. So that would be 81.8%. Okay, do you remember what it was when we used the empirical rule? This is the table value. The empirical rule, we got 81.5. This one's 81.8. Notice they are so close, but not the same thing. Okay, so let's try another one. Let's try part B, right? So if we're going to use the z-score, we're going to get out our little equation. For some reason, my pen didn't want to work. And I'm going to do this for 28, because that's what we're testing. So I'm going to do 28 minus the mean all over the standard deviation. When you crunch that in, you get 3. Okay, and by the way, I skipped this part, but let's look real quick right here. Here's my mean. 28's way over here, okay? Now, they want it to be more than 28, so they want it to be over here. When you look up the value in the table, it always gives you the value between the mean, so it's going to give me this value right here. So let's go look it up on the table real quick. We'll go find 3. Oh my goodness, I about chopped it off. But I can see right there that it says 0.499. Okay, so I'm going to go back. That means this area right here is 0.499. But I want this tiny little bit in the tail. Remember, on each side is 50% or 0.5. So I'm going to take 0.5 minus 0.4999, and that gives me 0.001. So again, that is the area under the curve. If you want to change it to percent, multiply by 100, which moves your decimal place 2 places, so that'd be 0.1%. Do you remember what it was when we used the empirical rule? Wasn't it 0.15? So super, super close to the same answer. But that's the difference between using the empirical rule versus the table.